Okay, if I cut this bar into the infinite number of slices, so every slice represent a cross section. Every slice represent a cross section. So this bar is made up of infinite number of cross section, and every cross section is a centroid. This is a square cross section, so its centroids it lie at the center. Okay, like here. If the dimension is a and this dimension is a, so the distance is a by 2 and this distance is a by 2. This is the centroid for the square cross section. If I join the cross section, if I join the centroid of each and every cross section, a axis is formed. This axis is known as longitudinal axis. This axis is known as longitudinal axis. Okay, so you should know in the centroid. I am telling you that while studying the mechanics subject, you should know how to find out the centroid of any cross section. Okay, so if you join the centroid of each and every cross section, you will form a axis which is a longitudinal axis. Okay, with respect to cross section. This is a bar which is the cross section. Here are the two categories. One is normal load and second is shear. Under the category of the normal, axial load and eccentric axial load. Under the category of the shear, for shear load is TSL, transverse shear load transfer. T stands for transverse, and eccentric transverse shear load. And here any kind of tension or compression. So this is the complete classification or based with respect to cross section. Now how to recognize it? Okay, select this. If this is a body, this is the front view. If you want to project this front view you will project on this plane. Plane of board means in vertical plane. This is the top view of this body. If you want to project on a plane, so you will project on the horizontal plane. Okay, and this is the cross section. This is the cross section of the body, and if you want to project on a plane, so you will project on this plane. This plane is nothing but the profile plane. Okay, so this is your vertical plane, this is your horizontal plane, and this is your profile plane. Okay, this is your cross section. If you apply normal load, if you apply a load which is perpendicular to the cross section, this load is perpendicular to the cross section, this load is known as normal load. If you apply a load which is perpendicular to the cross section, this is the centroid of the cross section. If you apply a load which is perpendicular to this section, like P, you apply the load which is passing through the centroid P. This is the load which is not passing through the centroid and having the eccentricity E, P. This type of load is known as the normal load. Okay, they may be here. This load is the compression in nature. Okay, now the normal load have the two category, axial load and eccentric axial load. If the applied load which is perpendicular to the cross section is passing through the centroid of the cross section, is passing over the centroid of the cross section, this load is known as axial load. This is the, if this is the cross section, if the applied load is perpendicular to the cross section and this is the centroid and passing through the centroid of the cross section, this load is known as the axial load. Okay, if the load which is perpendicular to the cross section but it is not passing through the centroid, it is having some eccentricity with respect to its centroid E. Now the load is applied here, this is the centroid. You are applied a load here P, which is having the eccentricity with the cross section, with the centroid of the cross section. Such type load is known as EAL, eccentric axial load. So this is the normal load. Okay. Now shear load. This is the module. This is the cross section. Okay. This is the centroid. If you apply the load, which is line of action is parallel to the cross section, which line of action is parallel to the cross section. Here, if you apply the load in this direction, means in this direction. This load, line of action of this load is parallel to this cross section. This load is known as shear load. Okay. Also, if you apply the load in this direction, the line of action of this force is also parallel to the cross section. This is also known as the shear load. Upload P and load P. This is known as the shear load. TSL. TSL. Transverse shear load. If you apply the load, which line of action is parallel to the cross section but passing through the centroid of the cross section, means this line of action of this load is parallel to the cross section but it is passing through the centroid of this cross section. This is known as TSL, transverse shear load. Okay. In the same way, if you apply the load here also, here I am representing load apply P, which is passing through the centroid. This is known as the TSL, transverse shear load. Okay. In the same manner, if you apply the load which is parallel to the cross section, this is centroid of the cross section, which is parallel to the cross section but having a eccentricity E, means this line of action of this force is not passing through the centroid of the cross section. This force type of loading is come under the category of the ETSL. ETSL, eccentric transverse shear load. Okay, eccentric transverse shear load means you applied a load which is parallel to the cross section but having the eccentricity, means which is not passing through the centroid, has come under the category of the ETSL, eccentric transverse shear load. So this is the complete classification of the load with respect to cross section, with respect to distribution, and with respect to the time. Once if you came to know that what are the loading conditions, if for example a member is giving to you, okay, this is the longitudinal axis, and whatever the load is applied here, you can see that a load is applied here, means which is line of action is parallel to the cross section but not passing through the centroid of the cross section. Means if here draw the cross section and this is the centroid, this is the eccentricity. So we can easily say that this is shear load. And what is the shear load? What is the normal load? So now here everything is, I hope so that everything is clear to you. What are the loading conditions? What is the SOM? How the SOM is important? Even I also like to tell you that in the ISRO interview, they give the most preference to this subject. So this is subject very important. Being a mechanical engineer, and you should have come on this subject. I hope you enjoy the video, and some of your doubt is clear by watching this video. If you have any question and a query, then leave your question in the comment box. Okay, thank you so much.